Hello dear friends, you all welcome back to Bodulwar Academy. Now see, the first lesson we have discussed parallax method, then the systems. Okay, now in the second lecture, we are going to discuss dimensions and dimensional analysis. Dimensions and dimensional analysis. तो देखिए, in the previous video, we have discussed that there are the seven fundamental quantities, that is mass, time, length, intensity. Okay, like that. Now see length. What is length? Each fundamental quantity should have some representation. जैसे कि M for male, F for female, M for male and F for female. तो देखिए ये दोनों ही ह्यूमन बींग्स हैं, लेकिन उसमें भी दो पार्ट है, मेल फीमेल. ओके, यानी कि रिप्रेजेंटेशन है माय मेल में. ओके, लाइक दैट. नाउ सी लेंथ. फर्स्ट फंडामेंटल क्वांटिटी इज व्हाट? लेंथ. And length should be represented by capital L. Then mass. Mass will be represented by capital L. Time. Time should be represented by capital T. Then temperature. Temperature. Kelvin. What? Kelvin. 5. Current. Capital R. Okay, like that we should have some notation, or you can say symbol for length capital M, mass capital M, time T, temperature K, and current I. Okay, now see how to derive the dimensions for any fundamental or derived quantities. What are derived quantities? So the quantity which depends on the fundamental quantity, that quantity is a derived quantity. Okay, now see, I have taken first term derived quantities, that is velocity is nothing but what? So displacement upon time. Okay, good. Now see, okay, am I write this like this? X into t units. Any problem? No. Now see here. There is no term of mass. Mass is how many here? 0. That's why I can write 1 second. Mass is here what? 0. Any problem? No. Now see. Dimension for V equals to square bracket. Now see here position. Position measuring what? Position, distance, displacement, length. Okay, so I am replacing this x by length. Okay, L1. Any problem? No. Now see here t, small t, but time is represented at capital T. Therefore, this t is replaced by capital T and minus 1 as it is. Okay, and here there is no terms of m. That's why we can write m0, m power 0, and this is the dimension for what? Velocity. Okay, पहले क्या करना है? जो भी फॉर्मूला है उसको ऐसे लिख लेना है. After that, just to replace position, distance, displacement by length, small t by capital T, and ms is it. We will see again. Now see acceleration. Acceleration is what? So velocity upon time. But velocity is what? Displacement upon time. Upon time as it is. Okay, इसको rearrange कीजिए. देखो क्या बन जाएंगे? x into t minus 2. x into t minus 2. Here m is what? 0. Therefore m power 0. Okay, very good. Now see. square bracket. Okay. In place of x, you have to replace capital M power 1. Now, in place of time, replace capital T. Minus 2 is M power 0. This is the dimension for what? Acceleration. Okay. Now see the third one, that is force. Force equals to mass into acceleration. Any problem? No. Now see, we have already found acceleration dimension and here is m. Okay, that's why, okay, in place of this small m, I can write capital M whole power 1. And now in place of acceleration, I can use this dimension. Therefore, L power, hello, L power 1, T power minus 2 and M power 0. ओके, देखिए इसको रीअरेंज कीजिए. देखिए बेस m लॉज ऑफ इंडाइसेस, बेस क्या है? सेम है, a b, देयरफॉर x और a plus b. ओके, m power 1, m power 0, m as it is 1 plus 0 1, therefore m power 1. now see, हेलो, क्या होगा तो इसको m power 1, l power 1, t power minus 2. This is the dimension for what? F equals to ma. Okay. In this way, you can find the dimensions of any derived quantities. Okay. Any derived quantities, you can easily find the dimension for any derived or fundamental quantities. Now we will see again for the density. Density. पहले तो आपको फार्मूला पता रहना चाहिए. Density is nothing but what? Mass per unit volume. Now see, mass per unit volume. Okay, no. Now see, mass volume measures in what? Sir, meter cube. What? Meter cube. Very good. Now see, this is mass, this will not get cancelled. Okay, now see, meter. Meter measures in what, sir? Your length. Very good. Then that means L cube I can write. Now see, m into L minus 3. L minus 3. Okay, density. M is replaced by m power 1. Small l is replaced by capital L minus 3. Okay, here time is 0, therefore t power 0. This is the formula for what? Density. अब देखिए, now we have derived the dimensions for the some physical quantities. But what are the application for the dimensions? कि किस काम का है ये चीज, किस काम की है? Okay, तो देखिए अब applications of dimensional analysis. The applications of dimensional analysis. The first application is to check the correctness of any physical equation. जैसे कि F equals to ma, is it correct or not? That's to check the equation is correct or not. We can use the dimensional analysis. Okay. Also, this is called as the principle of homogeneity. That is, equation कैसा रहता है? लेफ्ट हैंड साइड इक्वल्स टू समथिंग राइट हैंड साइड. अगर लेफ्ट हैंड साइड में डायमेंशन, if the dimensions on the left side is equals to the dimension of the right hand side, then the equation is correct. Okay, this is called the principle of homogeneity. Okay, now see, I will take the first example, that is v equals to u plus 18. This is the first kinematic equation. Here, this v is called as final velocity and this u is initial velocity. This is the acceleration and this is the time. Now we will see, is left hand side equals to the right hand side? Okay, it holds the principle of homogeneity. Now see, this is what velocity. You know velocity is displacement per unit time. I can write this. Therefore, dimension. X is nothing but distance. Distance is nothing but what? Line. Therefore, L power 1. Small t minus. Okay. Here M is 0. Therefore, L1 t minus 1 m0. This is the dimension for this velocity. That's why L1 t minus 1 m0. And this u is also velocity, displacement per unit time. Therefore, that's why the dimension for this u L1 t minus 1 m0. Now see. Now we have to check the dimension for acceleration into time. Acceleration into time. Acceleration is nothing but velocity per unit time into time. Time get cancelled. Therefore, v is nothing but displacement per unit time. Therefore, L1 t minus 1 m0. Therefore, L1 t minus 1 m0. Now, check the principle of homogeneity. That is, LHS should be equals to RHS. Check. L1 t minus 1 m0. L1 t minus 1 m0 plus L1 t minus 1 m0. Oh, the formula is right. देखिए समझ में आया? ओके, LHS इक्वल्स टू क्या रहना चाहिए? RHS. देखिए और एक एग्जांपल देख लीजिए. Now see. We will see the next. F equals to m. F equals to m into a. तो देखिए लेफ्ट हैंड साइड इक्वल्स टू राइट हैंड साइड हमें चेक करना है. देखिए F इक्वल्स टू क्या रहता है? पहले हम फोर्स का डायमेंशन निकालेंगे. ओके, हाउ टू फाइंड द फोर्स डायमेंशन? We know that force equals to m into a. Mass. Acceleration is nothing but velocity per unit time. And velocity is nothing but displacement per unit time upon time. Therefore, mass into distance upon t minus 2. Now, this small m is replaced by capital M1. Okay. And this displacement is replaced by L1 and t minus 2. Okay. This is your left hand side. What is M1, L1, t minus 2. Now, on the right hand side, there is a mass into acceleration. Acceleration is nothing but velocity per unit time. Okay. Therefore, velocity is nothing but displacement per unit time. That's why mx t minus 2. Therefore, m is replaced by capital M. X is replaced by L1. And t is replaced by t minus 2. That's why. Now you can see m1, L1, t minus 2. That is, the LHS equals to RHS. That's why this equation F equals to MA is correct. Okay? In this way, you can check whether the equation is correct or not. Okay? Using the dimensional analysis. Now see the second application of dimensional analysis. Now see the second application of dimensional analysis. That is, to establish the relation between physical quantities. It means you don't know the formula, but using dimensional analysis, you can formulate the formula. Oh, this is magic trick. Now see, example number first. Just they have given, they will give some relations. This term depends on this term. Then using that given condition, you can formulate. Now see, the time period of simple pendulum. Time period of simple pendulum is depends on length and acceleration due to gravity. Solution. What they have given, the time period of simple oscillation, simple pendulum, depends on length and acceleration due to gravity. Now see, time period is denoted by capital T. Okay, is depends on length. Depends on length. Okay, and depends on acceleration due to gravity. Okay, they have this much. They have given to this much of information. That is, the time period of simple pendulum depends on length and depends on acceleration due to gravity. Now see how to find the formula. In the first step, E is directly proportional to the L and G. I can write. Okay, L and G. Okay, because P is directly proportional to the both L and G. Now see, in this step, I am going to represent this L as a L power A and G as a G power B. Now T equals to, in place of proportionality constant, I am going to write the proportionality constant, that is K into L power A G power B. Okay, and this constant is dimensionless constant. Okay, this constant K is not called as proportionality constant, and which is a dimensionless. Okay, you can write L power A G power B. Now see, this is the equation number 1. On the left hand side, T is nothing but what? Time, which is a fundamental quantity. See, therefore the dimension for T, I can write T equals to dimension T1 L0 M0, because for time M should be 0 and L should be 0. Therefore T1 L0 M0. Proportionality constant as it is. L means what? Length. And what is the dimension for length? L1 M0 T0. Okay, L1 M0 T0. Therefore L1 M0 T0 whole power A. Now here G is nothing but acceleration due to gravity. Acceleration is nothing but velocity per unit time, but velocity is nothing but displacement per unit time. Therefore G equals to x y t square. You can write x into t minus 2. X is length. Therefore L1 t minus 2 m0. This is the dimension for acceleration due to gravity, right? L1 t minus 2 m power 0 whole power b. Now see, just rearrange. Okay, L power 1 into a, L power a, m power 0 into a, m power 0, t power 0 into a, t power 0, L power 1 into b, L power b, t power minus 2 into b, t power minus 2b, m power 0 into b, m power 0. Hello. Up to this, you don't have any problem. Now see, applying the laws of indices, here L power A and here is L power B. That's why I can write L power A plus. Is it okay? समझ में आया ना? देखिए, x power A to x power B. According to the laws of indices, the base is same. Therefore, base power A plus. Okay. In the same way, L power A, L power B. That is, base is what? L. L power A plus B. Now see, m power 0, m power 0, 0 plus 0, 0. That's why m power 0. Now see, e power 0, 0 minus b. How many? Plus 2b. Oh, minus 2b. Yeah. Come on. Now see, e power 1, l power 0, m power 0. Now, equating the powers of L, M and T. Okay, equating the powers of L, M and T. अब देखिए T का पावर यहाँ पे क्या है 1 और यहाँ पे क्या है T पावर minus 2b. Therefore, B equals to how many? Minus 1 by 2. Any problem? Now see. L power 0, L power A plus B. Therefore, A equals to minus B. Therefore, A equals to minus as it is. What is the value of B? Minus of 1 by 2. Minus gave plus. Therefore, A equals to 1 by 2. अब देखिए हमारा पहला इक्वेशन. Okay. In place of A, you can write 1 by 2. And in place of B, you can write minus 1 by 2. So now, put these values of A and B in equation 1. Therefore, equation 1 becomes equals to K constant, which is a dimensionless. Now, L power A is how many? 1 by 2 into G power B is how many? Minus 1. Okay, am I right like this? Yes. Now P equals to K. Now see, L power 1 by 2 upon G power minus 1 by 2. नीचे लेके आए. अब देखिए, now K as it is. Okay, square root of L upon square root of G. Therefore, T equals to K under root of L by G. This is the formula for a time period of a simple pendulum. Original formula क्या है? T equals to 2 pi under root of L by G. This is the formula. But now we don't have this constant value. But we define T equals to under root of L by G as it is. This is the magic of dimension. Okay? अब देखिए, ये हो गया हमारा सेकंड एप्लीकेशन. अब देखिए थर्ड एप्लीकेशन देखेंगे. Okay? Now, we will discuss the third application. Now see what is the third application? That is to find the conversion factor between the units of same physical quantity in two different system of units. Now see. So 1 kilometer equals to how many meter? Beta 10 power 3 meter. So 1 meter equals to how many centimeter? Beta 10 power 2, that is 100 centimeter. ठीक है. ये conversion factor हमको पता है. Sir, but I don't know the conversion of 1 joule equals to how many erg? Sir, I know joule unit is for the work done. Okay, ठीक है बेटा. You know this? Okay, I will find. Now see, our aim is to find what is the conversion between 1 joule equals to how many erg? 1 joule equals to how many erg? Here joule and erg is the units for work done, but joule is in a SI system and erg is in a CGS system. Now see, first of all, we should know the dimension for work done. I will write here the dimension of work done is L square. Wait, देखने दीजिए, गलत हो जाएगा. L square M1 T minus 1. Okay, ये आपको अब कैसे फाइंड आउट करने हैं पता ही है. Okay, what is the dimension for work done? L square M1 T power minus 1. Now see, in the left hand side, this is SI system and this is CGS system. Now I am writing this dimension like this: L1 square M1 power 1 T1 minus 1. Now here, why I write 1? Because on the left hand side 1 represents the dimension of SI system. Okay, x as it is. Now write the same work done, changing this 1 in place of 2, 1, t2 minus 2. Now see, in the right hand side, why I choose to write 2? Because in the right hand side, the unit is CGS. Okay, 1 represents SI and 2 represents CGS. Now, what you want? X. Therefore, X in the left hand side. Shift this L1 square M1 1 T1 minus 2. Okay, अब ये ब्रैकेट का कोई जरूरत नहीं है. ओके, टेंशन मत लो. देखिए L2 square M2 1 T2 minus 2. Now see, I can write this down like this: x equals to L1 upon L2 whole square using the laws of Lessons. Okay, ये तो आता नहीं भाई आपको. Okay, M1 upon M2 power 1. Okay, T1 upon T2 minus 2. Now see, 1 represents the SI system and L represents length. SI system में length कैसे denote करते हैं? Sir, meter. Okay. In place of L1, I am writing meter. And L2 represents CGS. अब ये जो length है, CGS system में कैसे represent करते हैं सर? Centimeter. Okay. Whole power 2. Mass represents SI system kilogram and in CGS gram. Okay, and time in SI or CGS second. S by S minus 2. Okay, now see, 1 meter is how many centimeter beta? 100. Okay, 100 centimeter upon centimeter square. And 1 kilogram means how many gram? 1000. Very good. Gram power 1. Second get cancel for 1 power minus 1. Centimeter get cancel. Now see, I can write 100 like this: in power 2 power 2. Gram get cancel. 10 power 3 power 1. Now see, I can write this down like 1 upon 1 square. 1 square is nothing but 1. 1 by 1 1. Therefore, I can remove it. Now see, 10 power 2 into 2, 10 power 4. 10 power 3 into 1, 10 power 3. This becomes 10 power 7. X equals to how many? 10 power 7. That's why in place of x, now I can write 10 power 7. Therefore, 1 joule equals to 10 power 7 match. Okay. Using the dimension analysis, I can find out the conversion factor. Okay, between the two different units or the same physical quantity. Now see, we have seen all the applications. Now we will see the limitations for these applications. Limitations for the dimensional analysis. Now see the first limitation. The value of dimensionless constant can be obtained with the help of experiment only. अब देखिए, जो हमने फार्मूला डिराइव किया था कि P इक्वल्स टू K इंटू अंडर रूट ऑफ L बाय G. क्या था यहाँ पे? डायमेंशनलेस क्वांटिटी. ओके, अब इसकी वैल्यू हम जो हमने मेथड यूज की थी उससे नहीं निकाल सकते. डायमेंशन एनालिसिस से हम मेथड से कांस्टेंट की वैल्यू निकाल नहीं सकते. ओनली विद एक्सपेरिमेंट, ओनली विद द हेल्प ऑफ एक्सपेरिमेंट we are able to find the dimensionless constant value. Now see the second limitation. Dimensional analysis cannot be used to derive the relation involving the trigonometric, exponential, logarithmic functions. यानी कि जैसे कि अब देखिए P equals to 2 times sin theta. अगर ये कौन सा भी फार्मूला है तो ये फार्मूला हम यूजिंग डायमेंशनल एनालिसिस नहीं निकाल सकते. Why? Because the trigonometric term is present, because the trigonometric, exponential and logarithmic functions are the quantities which are the dimensionless. That's why. Now see the third, this method is not useful if constant of proportionality is not a dimensional quantity. जैसे कि for example, the force between into mass according to the Newton, F equals to G m1 m2 upon distance का square. Now here the proportionality constant is G, but G is not a dimensionless. That's why for such a type of formulas this method is not applicable. Okay, तो ये थे हमारे कुछ limitations. तो अगली वीडियो से हम शुरू कर देंगे एरर एनालिसिस. ओके, तो देखिए, see you in the next video. सब्सक्राइब जरूर करना.